All right, so today we're going to talk a little bit about just a couple of trig identities and how they can be used to help you evaluate other trig functions. Our first set of identities are what we call the cofunction identities, and those say that if you know the sine of 90 minus some angle theta, that's the same thing as saying the cosine of that angle theta. So the question is, I always like to explore, why does this work? So our question here is why does this work? And to really understand this, we need to take a trip back to geometry. So let's go ahead and draw a right triangle. So here we have a right triangle, and I've just labeled one of my sides theta. So let's take a moment and think about how we could give this guy a name. So one of the things we know is that when we add up all of the angles in a triangle, we get 180 degrees. So let's just think for a minute if that angle is, B, okay? So if we take angle B and we add it to theta and we add it to 90, we should get 180 degrees. Well, how could we solve for B here? Well, first of all, I could subtract 90 from both sides, and I get B plus theta is equal to 90 degrees. What if I just want to know what B is? Well, I could subtract theta from both sides. And what I get is B is 90 minus theta. So instead of calling it B, I'm going to call it 90 minus theta. So this angle right here is 90 minus theta. Okay. So let's do two things here. I'm going to relabel the rest of my triangle with A, B, and C just to give it angle measures or letters so we can actually talk about it. And then across from angle A, we would call that side A. Across from angle B would be side B. And across from angle C would be side C. So let's just say I wanted to know what the sine of theta is. So the sine of theta means we would take the opposite side, A, and divide by the hypotenuse, C. Okay, well now let's talk about maybe the cosine of 90 minus theta. Well, the cosine function says let's do the adjacent side to that angle. So the adjacent side to 90 minus theta is little a. So that's going to be little a over the hypotenuse, which is C. And what you should notice is that these are both the same thing. And that tells you then that the two things that they're equal to, so sine of theta and cosine of 90 minus theta, must also be the same thing. So that gives us that idea that sine of theta is the same thing as 90 minus theta. So this first set of trig identities comes straight from just knowing how to use trig functions with a right triangle. Okay, there's a second set of trig identities that I'm going to have you write down as well. So this second set is called the reciprocal identities. And we call them the reciprocal identities because it is just showing that, sine is the same thing as the reciprocal of cosecant, and cosecant is the same thing as the reciprocal of sine. So algebraically, we would write it out like you see on the screen here. Now we can use these identities, the cofunction identity and the reciprocal identities, to help us find information about trig functions knowing something else. So what does that look like? All right, so let's say that I give you some information. I tell you that sine of theta is 2 over 11. And I ask you to find the following information. So the first thing I want us to find is the cosine of 90 minus theta. Now, if you look back up at your cofunction identities, 90 minus theta is just sine of theta, which in our case is just 2 over 11. So the cosine of 90 minus theta is just 2 over 11. I think I'll just circle that. Now, what if I asked you to find something else? What if I wanted you to just find cosine of theta? Well, that's a little bit tougher. So in order to do that, I've really got to think about what does this triangle look like? All right, so let's draw a triangle that we can then label. I'm going to draw a right triangle. All right, so I've drawn a right triangle. Now, I try to draw my right triangles generally in this orientation. We're going to talk about why that is in a future lesson. And then I've got theta labeled here at the bottom of the figure. So what I need to do is fill in what I know. Well, I have to be careful. So our given information is that sine of theta is 2 over 11. Well, that tells me, we know from our geometry days, that sine is the opposite side over the hypotenuse. So in my triangle, I can label those appropriately. My opposite side for this angle will be this side. So that will be the side that is length 2. And then the hypotenuse is the side across from 90. So what I have is this right triangle with a side length 2 and a hypotenuse length 11. If I want to find the cosine of that angle, I need to know what the adjacent side is. I need to know what A is. Well, in order to find that, I'm going to have to do, again, a little bit of work from geometry and use the Pythagorean Theorem. So I could take A squared and add it to 2 squared, and that should give me 11 squared. And then it's just a matter of solving that equation for A. So we get A squared is 117, and A is the square root of 117. Now, I would like us to try to simplify that if possible. And I do that by looking at whether or not 117 is divisible by any perfect square numbers. So what I can tell you right away is that it's not divisible by 2, okay? Is it divisible by 3? Well, maybe. And the way you can test that is to take 7 plus 1 plus 1, take the digits of 117 and add them up. And if the number you get is divisible by 3, then 117 is also divisible by 3. So I can tell it's divisible by 3, so maybe it's also divisible by 9. So I typed that into my calculator. I did 117 divided by 9, and I got 13. So this is really the same thing as saying 9 times 13. And then I know what the square root of 9 is. Let me fix that there. I know that the square root of 9 is just 3. So I can simplify that and make it 3 radical 13. So what I know now is that this side of the triangle is just 3 square root of 13. So if I want to find cosine, going back to the original question, I have to take the adjacent side, which is 3 square root of 13, and divide it by the hypotenuse, and that is the cosine. Let's just do a couple more really quickly here, and then we'll move on to another one. So what if I ask you to find the cosecant of theta? Now, we know the cosecant of theta is the reciprocal of sine. That's our reciprocal identity. So we don't really need to do any work for that. We can just go back up to whatever sine is and do the reciprocal of that value. So the reciprocal of 2 over 11 is just 11 over 2. What about the secant? Well, that's the reciprocal of cosine. So I can just take the reciprocal of this value. Now that gets to be a little tricky, right? So we have 11 over 3 radical 13. And we know by now, hopefully, that we don't like to leave our answers as something with a radical in the denominator. So I'm going to multiply numerator and denominator by square root of 13. And that's going to give me 11 square root of 13 over, we know this is 13, right? So we're just doing 3 times 13. So that's 39. So then the secant of theta is 11 radical 13 over 39. All right, let's try another one here. All right, so here's our given information. The secant of theta is square root of 50. Find each of the following. Okay, so in order to find cosine, I know that that's the reciprocal of secant. So I've got to think about secant as being a fraction, right? It's square root of 50 over 1. So if I want to find the cosine, I can just take 1 over the square root of 50. Once again, at this point, we should know that we don't like to leave the square root in the denominator. So I'm going to multiply by the square root of 50 over the square root of 50. And I get the square root of 50 over 50. Now, here's the thing. Your given information was not fully simplified. So the square root of 50 we can simplify, and I'm going to do that kind of off to the side here. So the square root of 50 I can think about as the square root of 25 times 2. Now I chose 25 because that's a perfect square. When I simplify that a little bit further, I can think of those independently And I can say, well, the square root of 25 is just 2. So what that means is that I can write the square root of 50 as 5 times the square root of 2. Now that's divided by 50. Now that I've done that, we should be able to simplify it a little bit further. 5 and 50 are outside of the square root, so I can simplify those just a little bit more. So I can make this the square root of 2 over 10. This is our fully simplified answer. Okay, what if I ask you to find the cosecant, so this, we'll just call this A. We'll call this B. What if I ask you to find the cosecant of 90 minus theta? Well, once again, this is one of our cofunction identities. And if you look up at your cofunction identities, it tells you that the cosecant of 90 minus theta is just the secant of theta. Well, that's what we were given to start with. So we could write the square root of 50, but we just found out that we can simplify that to be 5 times the square root of 2. Okay, let's try a couple more here. What if I ask you to find the sine of theta? This is going to require us to draw our right triangle and label the things that we know. So let me go ahead and draw my right triangle here. Just got to get my pen right. So my right triangle, again, I'm going to kind of draw it the same way every time. Theta will be down here, 90 is here, and I'm going to label the things that I know. Our original information was given to us as secant, so this is going to tell us our hypotenuse and our, I'm sorry, I did that backwards. Our adjacent side is in the denominator and our hypotenuse is in the numerator, because secant is the flip of cosine. And we know cosine is adjacent over hypotenuse, so then that means secant must be hypotenuse over adjacent. Now I'm going to use 2 times the square root of 5. I'm sorry, 5 times the square root of 2 for my hypotenuse, since I've already simplified it. And then my adjacent side for the angle is 1. So if I want to find sine, which is what I'm trying to do here, I have to know the opposite side. Well, that's here, and I'm just going to call that P. So in order to find the opposite side, I'm going to have to use the Pythagorean Theorem. So let's go ahead and do that. 1 squared plus P squared should be 5 radical 2 squared. So that's 1 plus P squared equals. Now 5 radical 2 squared, that means we're going to do 5 squared times radical 2 squared. Well, 5 squared is 25 times radical 2 squared is 2, so that's just 50. Keep solving for P here, and I end up with P is 7. Okay, so now I know the opposite side is 7. So if I wanted to find sine, I just have to do the opposite side over the hypotenuse. So that would be 7 over 5 times radical 2. And then once again, we don't like to leave our square roots in the denominator, so let's multiply by radical 2 over radical 2. And what we get is 7 radical 2 over, this ends up being 10. All right, so let's finish this up by just kind of working backwards with some information that we are given. So let's say I want you to tell me theta in quadrant 1. And I'm going to give you some trig ratio. So I tell you that the sine of theta is 1/2. And we're only concerned about our angles in quadrant 1. Okay, so thinking about our unit circle, we're only concerned about the angles in that first quadrant, so here. So if I'm asking you to figure out when is sine 1/2, so looking at your angles in quadrant 1, you're looking for when is the y value 1/2. And I think if you look at your angles in your on your unit circle, the first angle that we actually encounter is that angle 30 degrees. Now I want you to tell me what it is in both radians and degrees for this. So I would say that it's 30 degrees. It's also could be written as pi over 6. Okay, the second one says, now figure out when cosecant is the square root of 2. So we know the cosecant is the flip of your y coordinate. So if I look at my y coordinates for the other angles that I haven't talked about yet, the only one that looks like it could work is this one here. So I could say, okay, well, theta is 45 degrees or pi over 4. Now, I could check that. you know, what if I take radical 2 over 2 and flip it? Okay, so if I take radical 2 over 2 and flip it to get my cosecant, I get this. And then I would have to multiply by radical 2 over radical 2. And I get a giant 1. So yes, the cosecant of 45 degrees is radical 2. All right, last one. The tangent of theta is square root of 3. So this is telling me to take my y-coordinate divided by my x-coordinate, and I have to get radical 3. So I'm just filling in all my values here. Y divided by x. So I need to end up with the square root of 3 in the numerator. So that means that since I'm doing y divided by x, I would want the square root of 3 to be part of my y-coordinate. So it's most likely this point here, but I can test it and just make sure. So if I take y divided by x, square root of 3 over 2, divided by 1/2, a couple ways you can simplify that. I think I've shown you where we can multiply by the reciprocal in one lesson. But here I could multiply by 2 over 2, which is just 1, and it gets rid of my denominators and leaves me with the square root of 3 over 1, which is just the square root of 3. So the angle that works for that is 60 degrees, or we could call that also pi over 3. All right, that should be good for now. You can go ahead and do some practice with your homework tonight, and I'll see you soon.